Okay, we're going to start the numeric response here. So find the maximum area of a rectangle with a perimeter of 12. Okie dokie. Well, what on earth does that look like? Well, I don't know right off the top of my head, but I know that if I make that x and I make that y on my rectangle here, I know that 2x's plus 2y's has got to equal 12. Okay, that's the perimeter. There's 2y's, 2x's, and I can simplify that and make that x plus y is equal to 6. Okay, so that's the relationship implied by this part of the question right there. Now, it's asking me to find the maximum area of the rectangle. Okay, so area is the thing that I'm going to take the derivative of and set it equal to 0. Now I gotta solve for one of those variables there so I can get rid of it, and I think most of us would probably solve for y without thinking about it too much. So we're going to substitute that in so that our area expression is in terms of just one variable. In this case, it's just going to be in terms of x. So that'll be negative x squared plus 6x. Okay? Now, this is a parabola that opens down, so I know that when I take the derivative, okay, I'm going to end up finding that critical number, and it's going to be the vertex here. So now, the derivative of area will be negative 2x plus 6. And what I do with that is I'm going to set that equal to 0. So I'm going to bring the 2x term over. And so I will get 6 is equal to 2x. And when I divide, I get that x is equal to 3. Okay, so if x is equal to 3, therefore, if I come back up over here, okay, if x is equal to 3, negative 3 plus 6 is positive 3. And so area, okay, therefore, the area that we're looking for is x times y. That's going to be 9. And that makes actually perfect sense. It makes sense because the shape that I'm getting here at the as a result here is going to be a square. And if you think about it, yeah, that makes the most sense. The most efficient shape here would be a square.